Good day to my respected lecturer and my fellow friends. My name is Clarissa Anaparampuan Joseph, and today I would like to introduce about the geometrical concept that me and my friends have decided to work on in this assignment. Before that, I'll briefly explain the purpose why we took this geometrical concept, this particular geometrical concept and shape. As we all know, Islamic architecture is renowned for its intricate geometric patterns. We can witness this in mosque or in other cultural places. Okay, as far as I can remember, it's the mosque. These patterns often reflect Islamic principles, emphasizing unity, balance, and infinite nature of divine order. As I said earlier, mosque, often considered the heart of Islamic communities. It is also known as a place of worship for Muslims around the world. These sacred structures not only serve as venues for daily prayers, but also instill rich architectural traditions, reflecting diversity of Islamic cultures. Hence why me and my teammates, the other four of us, have decided to pick a wooden geometrical architectural pattern. As you can see in our slide, we have shown you guys the exact shape of that wooden geometrical pattern, which consists of several geometrical patterns that we will soon discuss after this. So clearly we took that from a mosque here in campus Sultan Azlan Shah, UPSI, the new campus in Proton City, Tanjung Malem, in a mosque called Masjid Al Murshidin. It is located near College Harun Aminur Rashid and College Awang Had Saleh. The purpose of this wooden geometrical pattern is to help believers focus and channel their attention of the viewer on his or her meditation, embedded with religious significance. Also, clearly, obviously, it serves as an art and appreciation of Islam as a religion and a culture. They were applied as decoration and expression elements. Last but not the least, the size of this geometric pattern is 332 cm of length and 130 cm of width. So if we calculate the area of this geometric pattern is 43,160 centimeters square. That's all from me. Thank you.
Now, to look at all the geometric shapes identified in the object. At first glance, you can easily see that the object is a rectangle. How do we come to that conclusion? Well, simply by comparing the object to the basic properties of a rectangle, which are: it has four sides where opposite sides are congruent to each other, and all four interior angles are right angles. We can say that the object we are looking at is a rectangle. Within the rectangle, we can notice many interesting and unique patterns. As we further analyzed the pattern, we discovered several geometric shapes within the rectangle. One of the many shapes we found is an irregular hexagon. It is classified as an irregular hexagon because, unlike a regular hexagon, this object has two sides that acts as the base of the object that are smaller than the other four sides. And unlike a regular hexagon, this irregular hexagon has unequal internal angles. However, like a regular hexagon, the sum of its interior angles is always 720 degrees, and its irregular hexagon also has lesser symmetry lines than a regular hexagon. The following shape that was identified was an octagonal star. An octagonal star combines an octagon's outer boundary, featuring 8 sides and angles of potentially unequal length, with an inner star shape formed by lines intersecting each vertex of the octagon. Typically exhibiting radial symmetry, each star point is equidistant from the center, with lines connecting them forming equal angles. The angles within the star are typically acute. The final shape recognized in this pattern is a rhombus. A rhombus is a quadrilateral, meaning it has 4 sides where all sides are equal in length. It is a special type of parallelogram, meaning opposite sides are parallel and equal in length. Unlike a rectangle, a rhombus does not necessarily have right angles. However, its opposite angles are still equal. The diagonals of a rhombus bisect each other at right angles, dividing the shape into 4 congruent right triangles. Rhombuses are most commonly encountered in various contexts such as diamond shapes, playing cards, and certain types of tiles. They possess unique geometric properties that make them useful in mathematics and engineering, particularly in fields like architecture and design.
Assalamualaikum and hello, my name is KARIM BINTI BINTI and my metric number is D2022110416X, and I will continue with geometrical concept. In this part, I will show you guys the measurement of each shape that I got from the wooden geometrical pattern, where I'm more focused on the side length, the area of the shape, and the perimeter of the shape. The first shape that we got from the wooden geometrical pattern is rectangular shape. As we know, rectangle is a parallelogram that has a right angle and only have width and height. So, since it is in 2D shape, we only can calculate the area and the perimeter of the rectangle. To calculate area, we can use formula width multiplied with height. Meanwhile, for the perimeter is the total sum of length side of the shape. After we calculate, we know that the area of the rectangular shape is 43,160 cm to the power of 2, and the sum of perimeter is 924 cm. The relationship of rectangle with geometrical concept, we know that the opposite side of rectangle are congruent since it is a parallelogram, and so the diagonal of the rectangle are also congruent. Next, we have shape irregular hexagon. Actually, if we cut this shape at the center, we can see clearly that this shape like as the combination of 2 trapezoids. Let's see one of the trapezoid. The measurement that we got is the bases of the trapezoid is 6 cm and 70 cm. Also, the height of the trapezoid is 7 cm. There are no specific formula to find the area of irregular polygon. So, to find the area of irregular hexagon, we must find the area of one trapezoid first, then multiply it with 2 because the trapezoid have the same shape and length. So, the area of irregular hexagon is 161 cm to the power of 2. Then we also can calculate the perimeter of the irregular hexagon by finding the total length of the side. The perimeter of the shape is 44 cm. This shape is called as irregular polygon because does not satisfy the properties of regular polygon, which is all side and angle have equal measure. So we can simply conclude that all side and angle of the irregular hexagon are not congruent. The third shape of the wooden geometrical is an octagonal star. This shape is very unique polygon, which is it is a star or regular polygon with 8-point polygon. To find its area, we can separate shape into the basic shape. We separate it into square shape and several triangle shape. Now it will be more easier to calculate. Area of square is 16 cm to the power of 2, and the area of triangle is 4.5 cm to the power of 2. To calculate the area of octagonal star, we have to calculate the sum of area of square plus with the area of triangle that was multiplied with 4, since the total of triangle we separate are 4. The area of the octagonal star is 34 cm to the power of 2. Now, let's calculate the perimeter of the octagonal star. To find the perimeter, we have to plus all the side length of the octagonal star since the length of the octagonal star are same. So, we can use formula perimeter of polygon, which is perimeter is equal to number of side multiple with side length. So the perimeter of the octagonal star is 48 cm, where 60 side of the octagonal star, we multiply it with length, which is 3 cm. The last shape is rhombus, where we know that rhombus was defined as a parallelogram with 2 congruent adjacent sides, and only have the bases and height. So the area of rhombus is the multiplication of the base and the height. Since we know that the bases and height is x cm, so the area of rhombus are 64 cm to the power of 2. And by the summation of the length side, which is perimeter, is 32 cm. And since we know that rhombus is one of the polygon in geometry and it is the same with parallelogram, so all the sides of the rhombus are congruent with the same measurement.
Okay, hello. Next, I will explain about transformation in motif and patterns. Here are the definition of transformation and isometric transformation. Transformation is a manipulation of a geometric shape or formula that maps the shape of formula from its prior image or original position to its image or after transformation position. While isometric transformation is preserve the shape and size of the given figure, where this transformation preserve length and angle measure that leads to a second figure that is congruent to the given figure. There are 4 types of transformation, which are dilation, reflection, translation, and rotation. But only 3 types that we use for this object, which are translation, reflection, and rotation. First of all, let's look at transformation in motif. Firstly, rotation. What is rotation? Rotation is when every point of the given figure leads to a point its image by rotation about a given point to a prescribed angle measure. So I take 2 pictures for rotation, and I already highlight the motif and also draw the x-axis and y-axis so that it can see clearly and more understand. For the left side, there is rotation shape of rhombus. How does this rotation happen? The object ABCD rotate in 90 degree anti-clockwise and form the image A prime, B prime, C prime, D prime. Now, let's move to the right side, which is orthogonal star. The object PQRSTUVW rotate in 180 degree clockwise and form the image P prime, Q prime, R prime, S prime, T prime, U prime, V prime, and W prime. Second, reflection. Reflection is when every point of the original figure is reflected across a line in such a way as to make the given line a line of symmetry. So, the line of reflection that I draw using the pink color is in vertical line, while the green ones are the types of geometrical shape that occur in this reflection transformation, such as rectangle, triangle, orthogonal star, rhombus, and irregular hexagon. The object of geometrical shape, for example, I choose the right side as object. So, the object is reflected across a vertical line and forming a flipper image which is slide at the same distance. Third, translation. Translation is that every point of the original figure is associated with a second point by locating it to a movement of a fixed length and direction. There are 2 motifs for translation, which are rhombus and irregular hexagon. Each object of rhombus and irregular hexagon are slided to the left to form the image. Last but not least, transformation in patterns. There are 2 patterns from wooden geometrical pattern. In the pattern 1, the geometrical shape is irregular hexagon, while in the pattern 2, there are rhombus and octagonal star, whereby these patterns can apply as their motif. Both patterns makes a repetition to form a complete motif in this pattern. And last, for transformation in patterns, the geometrical shape are located on the object to form a repetitive and consistent pattern by applying the concept of transformation, which is translation, rotation, and reflection. So that's all for me. Thank you.
We have reached an outcome that this wooden geometric pattern have included several polygon shapes in its design. For instance, it included trapezoids, octagonal star, and also rectangles. The size of this geometric pattern is 332 cm in length and 130 cm in width. Hence, after we calculate the total area of this wooden geometric pattern, we obtain 43,160 cm per square as its total area. This pattern was used to symbolize Islamic principle emphasizing unity and balance, and also as infinite nature of divine order. In short, geometry are a study about shapes, size, and also position, and it can be observed in our surrounding as well, for example through traffic sign, buildings, arts, and many more.